Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Virtualization and cloud computing are fundamental components of modern information technology infrastructure, enabling more efficient use of hardware resources and flexible deployment of services. They allow computing environments to be created, adjusted, and scaled without requiring direct one-to-one hardware allocation. The CompTIA Tech Plus exam measures understanding of these concepts, including virtual systems, cloud service models, and deployment types. This section explains the foundational ideas, the technologies involved, and the terminology you need to know. Virtualization is the process of creating simulated computing environments or machines inside a physical system. These virtual machines operate independently, each with its own operating system and dedicated virtual resources. A single physical computer can host multiple isolated systems, each running workloads as if it were separate hardware. This approach improves the efficiency of resource use, ensures isolation between environments, and allows for more flexible management. A hypervisor is the core software layer that enables virtualization by creating and managing the virtual machines. It allocates resources such as central processing unit cycles, memory, storage, and network connections to each guest system. Hypervisors allow virtual machines to operate independently of the host operating system, enabling multiple environments on a single machine. There are two primary categories of hypervisors, known as Type 1 and Type 2. A Type 1 hypervisor, also known as a bare metal hypervisor, runs directly on the physical hardware without the need for a separate host operating system. Examples include VMware ESXi, Microsoft Hyper-V, and Citrix XenServer. This design offers better performance, more direct resource control, and higher efficiency. Type 1 hypervisors are most often found in enterprise data centers and large-scale cloud platforms. A Type 2 hypervisor, also known as a hosted hypervisor, runs on top of an existing host operating system such as Microsoft Windows or Mac OS. Examples include Oracle VirtualBox, VMware Workstation, and Parallels Desktop. These hypervisors are easier to install and use, making them popular for development, testing, and training purposes. Their performance is limited by the stability and efficiency of the underlying host operating system. Each virtual machine runs its own separate operating system, which is called the guest operating system. This guest can be completely different from the host operating system, for example, running Linux on a Microsoft Windows host. Multiple guest systems can run at the same time, fully isolated from one another in their own environments. All guests share resources such as memory and processor time with the host system and any other virtual machines running. A hypervisor controls the allocation of virtual resources such as virtual central processing units, virtual memory, and virtual storage to each machine. Administrators can assign limits to prevent conflicts and ensure balanced performance between systems. Over-allocating resources can result in performance problems and instability. Monitoring tools are used to track usage over time and adjust allocations as needed. Snapshots and cloning are two important features that support the management of virtual machines. A snapshot captures the exact state of a virtual machine at a given moment, allowing a rollback to that state if necessary. Cloning creates a complete copy of an existing machine for testing, development, or rapid deployment. Both functions are useful for disaster recovery, experimentation, and version control in virtualized environments. Virtual networking allows virtual machines to communicate internally or with external networks through virtual switches, network address translation, or bridged connections. This enables administrators to build simulated network topologies without additional physical hardware. These configurations can be used to test firewall rules, network services, or client-server applications. Isolating virtual networks improves security and ensures controlled traffic flow. Virtualization offers multiple benefits that are relevant to both real-world operations and the exam. It reduces hardware costs by consolidating systems onto fewer physical devices. It simplifies development and testing by providing isolated environments that can be created or removed quickly. Features such as live migration increase system uptime and reduce service interruptions. Virtualization also enables flexible backup, recovery, and load balancing strategies. Virtualization has limitations that must also be understood for the exam. Performance overhead exists because resources are shared between virtual and host systems. Large environments can be complex to manage, requiring advanced administration tools. Licensing and compliance rules must be considered for each operating system and application used. Certain advanced virtualization features depend on hardware support, such as specific processor extensions. Cloud computing is the delivery of information technology services over the Internet, allowing users to access computing resources without owning or maintaining the physical infrastructure. This approach makes it possible to use computing power, storage capacity, and software applications on demand from any location with Internet access. Cloud services are designed to be scalable, subscription-based, and highly available to meet changing business needs. Virtualization technology is the foundation on which cloud computing operates. There are three primary cloud service models that must be understood for the exam: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service provides access to virtual machines, networking, and storage resources that the customer can configure. Platform as a service delivers development tools, application frameworks, and hosting environments for software deployment. Software as a service delivers fully functional applications through a web browser, eliminating the need for local installation or maintenance. Infrastructure as a service gives users control over their own virtual machines, operating systems, and applications, while the cloud provider manages the physical hardware and virtualization layers. This model offers flexibility for building and running custom environments without capital investment in servers. Well-known examples include Amazon Web Services EC2, Microsoft Azure Virtual Machines, and Google Compute Engine. Infrastructure as a service is ideal for organizations that need dynamic infrastructure without owning physical equipment. Platform as a service offers a managed environment for developing, testing, and deploying applications without managing the underlying servers or operating systems. This service includes programming frameworks, databases, and deployment tools pre-configured by the provider. Examples include Google App Engine, Microsoft Azure App Services, and Heroku. Platform as a service reduces the time and complexity needed to bring applications online and is well suited for development teams. Software as a service provides complete, ready-to-use applications over the Internet, which are accessed through a web browser or thin client. Users interact only with the application interface, while the provider handles server infrastructure, updates, and security patches. Common examples include Microsoft 365, Google Workspace, and Salesforce. Software as a service is quick to deploy, requires no local installation, and is widely used for productivity, collaboration, and customer relationship management. Cloud deployment models describe where the infrastructure is located and how it is managed. A public cloud is owned and operated by a third-party provider and shared among multiple customers. A private cloud is dedicated to a single organization and can be hosted on-site or at a provider's data center. A hybrid cloud combines public and private cloud environments, allowing workloads to move between them. The choice of deployment model depends on security, control, and budget requirements. On-premise computing requires upfront capital investment, dedicated physical space, and ongoing maintenance of hardware and software. Cloud computing offers flexibility, a pay-as-you-go pricing model, and the ability to deploy services rapidly. Cloud services remove the need for hardware lifecycle management and reduce downtime. Many organizations use a combination of on-premise and cloud resources to meet regulatory, performance, or cost management needs. In public cloud environments, providers operate large-scale virtualization using Type 1 hypervisors to host thousands of virtual machines for customers. Users rent these virtual machines through web portals or application programming interfaces. This architecture allows for automatic scaling, redundancy, and distribution of workloads across geographic regions. The same principles used in local virtualization apply, but on a much larger scale with additional automation. Security remains a major concern in both virtualization and cloud computing environments. Virtual machines must be maintained with regular security patches and monitored for vulnerabilities, just like physical systems. Cloud providers use a shared responsibility model where the provider secures the infrastructure while customers are responsible for securing their data and applications. Isolation of virtual machines, encryption of stored and transmitted data, and properly configured firewalls are essential security practices. Misconfigured cloud resources are a frequent cause of data breaches. Cloud services are accessed and managed through various tools, including web-based dashboards, command line interfaces, and software development kits. These tools allow administrators to automate deployment, scaling, monitoring, and resource management. Understanding how to use these interfaces helps bridge the responsibilities of infrastructure, development, and operations teams. IT professionals working with cloud services must be proficient with at least one management method for efficiency. The glossary terms relevant to this topic include virtualization, hypervisor, guest operating system, infrastructure as a service, platform as a service, software as a service, virtual machine, snapshot, and cloud deployment model. Studying these terms alongside practical examples strengthens exam readiness. Organizing the terms into groups based on service models, virtualization components, or deployment types can help with faster recall. In practical environments, service desk staff may be responsible for troubleshooting access issues to software as a service applications or diagnosing performance problems in virtual machines. System administrators may design and maintain virtual test environments or manage large cloud storage deployments. Developers often use platform as a service to launch applications without managing infrastructure. A solid understanding of virtualization and cloud technologies is a critical skill in modern IT job roles. In the next episode, we will compare cloud deployment models, focusing on the advantages and limitations of public, private, and hybrid solutions. We will also explore how each model supports different business goals and technical requirements. This knowledge will help you determine the most effective approach to deploying and managing services for various use cases. Join us for Episode 27, Cloud Delivery Models, Software as a Service, Platform as a Service, and Infrastructure as a Service. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.